one, we have the sum of two cubes here. 216 is a perfect cube. X cubed is obviously a perfect cube. And 1 is the smallest perfect cube because what times itself 3 times is 1? 1. All right, so this one can be broken up into the little parentheses and the big parentheses. Now the sum of two cubes, what do the signs do?
Plus, minus, plus.
Correct. Plus, minus, plus. All right, so to fill in the first set of parentheses, the little one, you take the cubed root of the first term. So what's the cubed root of 216?
14.
6. And then what's the cubed root of x cubed?
1.
X. So just the 1x. All right, and then what's the cubed root of 1? 1. All right, so now to get what goes in my first spot, I look at the first term here, and we square it, all of it. So 6x
36x
squared. Right, so you square both of them.
Wait, I'm lost. How did you just get 6?
Because 6 times 6 times 6 is 216.
Is it really?
Yes.
Wow.
That was one of the ones on our list. I think that's the last one we did. But you'll see that one kind of a bit. Then after that, you might see numbers that are bigger than that, but usually not very often. All right, and then you take the second term and you square it, and that's what goes out here. So what is 1 squared?
1.
Still 1. And then in the middle, you multiply these two terms together.
6.
That's the factored version of this.
So the first set of parentheses, you're just cubing the terms.
Correct.
And then everything else is...
Cubed rooting the terms.
Okay.
Right. And then the rest of this comes from that first set of terms.
Okay.
And then there's, I don't know, that's always the way that it was explained to me, and that makes pretty good sense. Because the nice thing is that it works the same way for the difference of two cubes. The only difference is the signs. All right, this one's a little bit different because is 32 a perfect cube? No. X cubed is, obviously, is 4 a perfect cube. It is not. All right, so I'm going to have to do something to this one before I factor it. So 32 and 4, what do they have in common? 4. All right, so first I can undistribute out a 4. So what would I have to multiply the 4 by in order to get this again? X cubed. And 4 times what gets you 4? 1. All right, now is 8 a perfect cube? And we know that x cubed is 1? Okay, so now I can factor what's in there, and this 4 is just going to be out in front. So I still have a little set of parentheses and a big set of parentheses. This one is the difference of two cubes, so what do the signs do?
Plus, minus, minus.
Close.
Well, minus, plus, plus.
Right. All right, so just like we did in the last one, what's the cubed root of this first term?
2x.
The cubed root of 1? All right, so then I take the first term, 2x, and I square it.
4x squared.
Take the 1 and square it, and then multiply them together.
Cool.
That's the completely factored version of that. This one's real similar. 2 is not a perfect cube, and neither is 54, but they have something in common. 2, they're both even. So if I pull them out, I'm going to get x cubed plus, what is 54 divided by 2? Okay. Now, is 27 a perfect cube?
It is.
Then we're good. So I still have that 2 out in front. I'm going to have a little set of parentheses and a big set of parentheses. What are my signs doing?
Plus, minus, plus.
Good. All right, cubed root of x cubed. Cubed root of 27. All right, then I square the first term, square the second term, multiply them together. That's that. Only factored.
These aren't hard at all.
They're not bad once you get the pattern.
Yeah.
There's a little bit of memorization, though, involved. All right, 4 terms is usually the grouping type. And they don't always work, but all the ones they gave you in the homework did. So you just have to pair them up however you want. I just went with the first 2 and then the second 2. All right, so the first 2, that's the easy one. What do these two things have in common? 10. Anything else?
X squared.
X squared. What would that leave me behind with if I undistributed that out? No. Because it'd have to be 10 times something gets me the 20. So a 2. Okay, now the green one, now remember, what I'm supposed to end up with this for both of them, right?
Yeah.
Okay. But I already have an x plus 2 out here. Right? So if I put that in the parentheses, what did I factor out of here? Technically. A positive 1. Right? There's always a 1 in front of every set of parentheses if there's nothing else there. Right? And that's kind of the tricky part. So you may or may not have seen that. All right, so then I take the two things that are out in front, and those go into one set of parentheses. So I get 10x squared plus that 1 times the two things that they had in common, x plus 2. And then whenever you get to this point, you always want to make sure, can I keep factoring or not? Does x plus 2 factor anymore? No. How about 10x squared plus 1? No. Because usually it would be a difference of 2 squares, but those are not. So this is as good as that one gets. I think this one's a lot more straightforward than the last one, because the last one had that 1 that you had to mysteriously pull out. This one's going to be much more straightforward. If I put these two together, what do those two terms have in common? An x squared. So if I pull that out, what will I be left with here? And here? Okay. And then I can do these two. What do they have in common? A positive 10. So if I pull that out, what will I be left with here? Yep, which is what I wanted because I wanted these two things to match. All right, so I take the two things out in front, x squared plus 10, and I multiply that by the thing that they had in common. And that's going to be it for that one because x squared plus 10, you can't factor that anymore. X plus 3, you can't factor that anymore, so that's as good as that one's going to get. All right, now chances are you guys are better at these, or you're going to be better at these than I ever was when I took Algebra 2.
Oh, I know how to do this.
Okay, you got an idea?
Yes.
What do you want to do?
It's just factor.
It is. Now, most of you guys are going to be able to do this in your head, right? But what's the only difference? This problem, it has 3 terms, just like we're used to. So it looks like one of those quadratic form ones where I could just factor it the way it is, right? What's the difference?
The things are bigger.
Yeah, the powers are different. They're actually double what we're used to. We're used to that first term being an x squared plus 4x minus 21, not an x to the 4th plus 4x squared minus 21. But you can do them the same way.
We have to divide it by 2 or something.
Sort of. That's how I always did it because I was not good at being able to look at these. I don't know, that 4 out in front or that bigger power out in front always threw me off, right? But if you have 3 terms and you recognize it as a quadratic form, right, you can try this, right? And this is what I always did in Algebra 2. I still do them this way just because it's easier for me to look at. So instead of having an x to the 4th here, I'm going to let y equal x squared and substitute y's in to make it a little bit easier. So that means that instead of being a 4x squared here, what will this be then?
2.
No. I'm going to let y equal my x squared. So this will be a 4y minus 21. The harder one is what will x to the 4th be then?
2y.
Nope, you're close.
Wait. Y to the 4th.
No, it's an x to the 4th now. I'm trying to get rid of that 4.
Y squared.
Y squared. Because if I square a squared, I would get a 4th, right? So now this looks like something that we're used to, and that factors, right? So I let y equal x squared, and I substituted. Now I'm going to try to solve this thing. So this will be y. What will my signs be doing?
Plus minus.
Multiply together to get 21, but a difference of 4.
7.
Which one's the big one?
7.
Or I mean the positive one?
7.
Okay, so it factored, right? But then, so I solved it. but it wasn't a y, so we back substitute. We put it back the way we found it. So what should I be plugging in for all the y's? X squared. Now, can I factor x squared minus 3 anymore? There's a difference. Are they both perfect squares? 3 is not, so that one's out. This one's not even a difference, so I know I can't do anything more with this. That's it. Now, my guess is more than half of you guys will be able to just go straight from there to there. And if you can do that, great. But if you're struggling with it, you always have this substitution thing that you can fall back on. So in this case, I didn't need to factor more.
So from right from the start, we can just like make it x squared and then find it out and then just plug it in.
That's what I do. If I don't change it to x squared, I don't use x's because they're already x's, so I pick something else. And that's why I went with a y. So you turn it into a quadratic like you're used to, but then you have to remember it's not really a quadratic, so you have to put it back once you factor. And then see if you can factor a little bit more. Let's see if I got another example down here. All right, this one's kind of the same, but I've got 2 terms this time. But we could try the same method. So let's let y equal x squared. So what if I have y's in here, what will this one be then? Okay, now 81. I only have 2 terms, so I should be thinking that this is the difference or the sum of 2 squares or cubes. What would this one be?
9, 4.
Okay, so it's a difference of 2 squares. All right, so I'm going to be able to factor this into 2 little parentheses. What's the square root of 81y squared?
9.
Okay, so 9y, and then the square root of 16? Plus, minus. All right, but we weren't supposed to be using y's, we were supposed to be using x squared, so we put those back. Right, and then after you put it back, you always want to make sure, can I keep going, or am I done? Right, does 9x squared plus 4 factor anymore? Plus 4?
Yes.
This one does not. But 9x squared minus 4 does, because that's a difference of 2 squares.
What's the one?
9 is a perfect square, x squared is a perfect square, and 4 is a perfect square. So that's the difference of 2 squares. And we know that that factors into, what's the square root of 9x squared? What's the square root of 4? But there is no formula for the sum of 2 squares, so that one has to stay the same. There is formulas for the sum and the difference of 2 cubes, but I did not have that situation this time. That is the most factored form you can get of this.
You can only simplify more when it's minus the whole number.
Right, and everything in there has to be a perfect square, right? Because if you look back up here to the first example, I had an x squared minus a whole number, but 3 was not a perfect square, so I couldn't keep going. If it was a 4, I would have been able to keep going, or a 9, or a 25, or a 16. Okay. So that's why this one was kind of unique. I had a 9 and a 4 and an x squared. Everything in there was a perfect square, so I could keep going. Here, I didn't even have a difference, so it has to stay the way it is. Now, my guess is more than half of you guys are going to be able to immediately go from here to here without that substitution step. And if you can do that, great. I was never good at that. So if you got to do the substitution thing, don't feel bad. I do the same thing.